Welcome to the Ubiquiti Solar Residential Specialist online course. This course is divided into 3 modules. Each module contains video lessons designed to teach you the fundamentals of residential solar while engaging the software and hardware aspects of Ubiquiti's SunMax platform. After each video lesson, there is a corresponding question review, which you should complete to assess your understanding of the previous lesson. When you've finished all of the lessons, you will receive an electronic certificate of completion for your participation in this online course. At any time, feel free to talk with us on the Ubiquiti online user community. And now, SunMax. Lesson 1.1, SunMax and the Solar Business Opportunity. Across the world today, the renewable energy market for residential customers is growing at an unprecedented rate for 4 primary reasons, including rising costs in energy from power companies, decreases in cost, as well as improvements in efficiency of renewable technology, and financial incentives for consumer investment. Faced with these conditions, the residential solar market today has achieved grid parity. Grid parity occurs when the cost of renewable energy systems, such as grid-tied solar, drop to, and more often below, the energy costs charged over the long term by local power companies, called utilities. As an ISP, you're accustomed to monthly revenues that accumulate for each customer you add and the service that you provide. Compared to internet subscriptions, residential solar energy systems appeal broadly to customers and integrators alike, given the no-money-down financing options, as well as a high return on investment. Based on your company's infrastructure, background in sales, and existing customer base, you are already in a strategic position to move into this very lucrative market. Ubiquiti's SunMax residential platform empowers ISPs in a number of important ways, unique from any other manufacturer. First and foremost, through cost. Priced at just $1.50 per watt, the SunMax brand breaks down economic barriers for customers worldwide, allowing you to aggressively campaign and dominate your local solar market. Secondly, through education. In addition to a helpful online user community and knowledge base, Ubiquiti's free online SunMax training course is designed for individuals with no prior experience in the solar field, providing in-depth knowledge on how to effectively sell and install SunMax residential systems. And finally, through ease of use. Sunlink is Ubiquiti's free online software suite that simplifies system design, generates customer proposals, and accelerates the permit application process. SunMax also features an intuitive plug-and-play design so installers can rapidly deploy systems. To review, across the United States and world today, favorable market conditions allow renewable technologies like solar to reach grid parity and gain popular market share. As a wireless ISP, you are uniquely set up and favored to capture sales in this lucrative market. Ubiquiti SunMax is a complete, all-in-one system revolutionizing the solar energy market through ultra-low costs, quality education, and a remarkably intuitive experience for you, the end user.
SunMax, Business and Sales Training. Part 1, Growing Your Business with Solar. Solar is one of the fastest growing industries in the world and shows no signs of slowing down. Last year alone, there was more solar installed globally than in all years previous to 2011 combined. This extreme growth indicates that the solar industry is primed and ready to offer a profitable opportunity to those willing to enter solar. Ubiquiti created SunMax to make entering solar more profitable and easy than ever before. In the typical solar install, customers pay for or finance the total install cost. This includes the cost of hardware, install-related costs like labor, permitting, electrical work, etc. The remainder makes up the net profit margin for the installer. SunMax installs feature a much lower cost of hardware than the market average. SunMax also helps reduce installer costs and overhead dramatically. This ends up giving SunMax installers much more room to profit than their competitors, while still providing the best available price to customers. How much can you expect to profit with SunMax? Let's take a look at the numbers. For the average SunMax residential install, after expenses, the installer will profit an average of $2,000 to $5,000 in upfront cash. This varies based on the size of the system and the price it was sold to the customer. If you sold an average of 1 system every month, This means a total additional profit of around $30,000 to $60,000. Now let's say you doubled that and installed 2 systems a month. In a year, you'd be looking at a net profit of between $60,000 and $120,000. As these profits show, SunMax offers a new, high revenue stream to add to your business that will continue to grow for years to come. SunMax Business and Sales Training Part 2. Add to your profits with SunMax. SunMax was built to be affordable and easy to install and comes packaged with a suite of free tools and services that are normally an added cost to the installer. In this video, we will show how with a low price point and free tools and services that every aspect of a solar business from hardware to permitting is more profitable with SunMax. Let's start with hardware. On the left, we have the estimated SunMax price. On the right, we have the reported industry average for installs. SunMax hardware is available at a cost of about $1.35 per watt, as opposed to the average of $1.81 per watt for the industry. What's great about this is that SunMax doesn't require to buy in large quantities to get the best price. This allows smaller install companies to offer better cost savings to potential customers with a more competitive price. As shown, a lower cost of hardware with SunMax means less money spent on sales tax. Additionally, SunMax helps to dramatically reduce install times. Labor for an average SunMax install should take only 2 to 3 hours at most, as opposed to the reported industry average of 1 to 2 days. This leads to much reduced labor costs. SunMax also empowers existing service providers to sell solar without expending extra resources. To help sell SunMax, you have at your disposal free professionally designed marketing materials, the sales proposal software, as well as plenty of documentation to help grow and scale your new solar business. All these free tools and services offset the cost of solar business to make your company capable of installing solar without adding unnecessary overhead. SunMax requires no warehousing as it is immediately available from any of our certified SunMax resellers across the United States, the EU, and rest of the world. Another way in which SunMax offers immense value is permitting. Once you collect the necessary information, Ubiquiti's team of professional engineers will design and create building plan sets at no cost. This adds great value through both the cost of these services as well as diminished overhead. All these different aspects of the solar business add up to make a huge difference. This plays a direct role in ensuring that SunMax installs yield much more profit than the average solar system. In other words, SunMax installers can afford to sell at a more affordable price than their competitors while still adding to their profits. These advantages make SunMax a slam dunk both for the prospective solar installer as well as the homeowners to which they will sell. SunMax Solar Business and Sales Training Part 3. Preparing your solar business to succeed. Getting started is usually the hardest part of making the move to solar. While many of you know how to operate a successful business as a service provider, there are considerations with respect to solar that are important to understand and keep in mind to best help your business find success. In this video, we will discuss how to best get your solar business started out on the right foot. To help develop a vision of a profitable new solar business, it may be helpful to develop a business plan. This may include the following: business goals, profit and overhead estimates, who you will market to, competition and market analysis, and necessary steps to move forward. To get an idea of what this looks like, let's take a real-life example from an actual SunMax installer, Kyle from Ohio. Kyle had worked with Ubiquiti products as a consultant. Once he knew that Ubiquiti was putting out a solar product, he started looking into the viability of starting a local solar business. He began researching his local solar market and how he could best angle his business for success. Here's what his basic business plan looked like. Given the limited distribution of solar in Ohio, there are very few options for homeowners to choose from. The low price of utilities in the region means that existing solar options typically offer a poor return on investment for customers. With the extremely affordable price offered by SunMax, Kyle was positioned to provide solar to a larger base at a significantly better price than the competition, while also being a very profitable enterprise for him and his partners. Because of the limited competition and immense advantage he had with SunMax, he saw that he and his company could grow into being a leading solar provider in his area. He planned a website, marketing, and how he would utilize his network to get leads. He executed his business plan and is continuing to grow his business, SunPowered Solutions, to this day with great results. When looking at creating your business plan, here are some questions to keep in mind. What are local regulations concerning solar? What is required to be a solar contract in your area? Will you need to find added install staff and an electrician to partner with? How will you find them? How will you help clients find financing? What leads will you start with? How will you generate further leads? Where will you order your SunMax hardware from, and how can you limit shipping costs? If you need help answering these questions, use our knowledge base articles, reach out to our SunMax support team for help, or bring up a discussion in our community. Our remaining videos will help provide answers to these questions and also give a greater description and understanding of how to run a successful solar business. SunMax, Business and Sales Training, Part 4, Building a SunMax Sales Strategy. All across the world today, homeowners choose solar for the thousands of dollars in cost savings a system like SunMax brings them. The success of your business hinges on your ability to present to customers the safe and easy yields of the solar investment. In this video, we'll help you launch an effective sales campaign by focusing on two objectives. First, identifying and understanding your target market, and second, making a strong personalized sales pitch. Let's talk about your target market. Recent trends in the solar industry have suggested that smaller regional solar companies are best positioned to meet the demand for solar in a changing environment. To help you capitalize on this, you need to understand how to serve your target market. Here are some questions you will want to answer in your research. Is the home solar market in your area new, established, or emerging? Do regional utility rates and patterns favor home solar? Who is your competition and at what price do they sell? What incentive programs are available to help appeal to leads? Who are your current leads? How would they benefit from solar? Once you research and understand these questions, you have all the information you need to craft a strong, personalized sales pitch. Let's show through an example of how to do this. In this scenario, let's imagine you're a new solar installer in rural Indiana. Market research in rural Indiana shows that solar is an emerging market where less than 1% of homeowners have solar. Due to rapidly dropping solar costs, only recently did solar become a viable option. You find that SunMax uniquely positions you to succeed by allowing you to outsell the very limited competition while still running a profitable business. Most people you ask about solar are unaware of how much they could save and still think it's not viable for them. You can conclude that solar is a good option for most people in your area, especially those with larger homes and south-facing roofs. To start with leads, you're planning to work with your wireless customers and find a few that would be ideal for solar. How would you sell solar to this target market? Here are a few ideas. First, lead in with information that will counter the existing misconceptions that solar is too expensive or not viable for people in Indiana. Explain with numbers that a SunMax system would be profitable for most homes in Indiana. Do not assume that your clients understand how solar savings work and explain it thoroughly. Next, to ensure the customer is convinced by your claim, create a sales proposal for the customer's home. Ask to see their energy bill if possible to ensure you have accurate information. When showing them the proposal, emphasize cost savings and affordability. At this point, they're likely to be impressed with savings, but may still be concerned with the cash flow required to purchase the system outright. Identify specific financing options in Indiana and emphasize the ease by which these can be obtained and still provide ample cost savings. Address any other concerns or questions the customer has and finalize terms. Wherever your solar market is, there are many homeowners who need solar and simply need the right pitch to convince them. In more saturated markets, SunMax's low cost allows you to reach less affluent neighborhoods and demographics. In areas where sentiment towards green energy is especially positive, you may find that more success by emphasizing the amount of energy produced by the system and the positive impact offered to society. Find the right pitch for your customers, and SunMax will help you close the deal. In our next video, we'll explain how you can market your business and what materials you can use to further expand your client base. SunMax, Business and Sales Training, Part 5, Marketing Your Solar Business. As your solar business gets started and you complete your first installs, generating leads and converting these leads to sales is critical to build and maintain momentum. In this video, we'll go over some ideas for how to best reach your target market through a marketing campaign. First, let's discuss the importance of a website to your marketing efforts. Building a website for your solar company can be very helpful in generating business. A website provides a means to generate leads, to facilitate contact with customers, lends credibility to your company, and can showcase the value offered by SunMax and your install services. Another resource to increase your reach in your market is to set up a booth at local events like fairs and trade shows to advertise your services to potential customers in your area. Given that many people are unfamiliar with solar, it's critical to reach people who wouldn't be likely to find your company through the Yellow Pages or Google search. Setting up a booth at events like this will help you to do that. Advertisements are another potentially valuable option to market your product. Depending on what works best in your area, newspaper, radio, or billboards could all be effective mediums for ads. When starting out, it's best to minimize the expenses related to advertising, as to not overinvest or put too much financial pressure on your sales. This is why SunMax has free customizable advertising materials to help you get your business rolling. Advertise in a secure way by using these materials for whatever application you feel will be most effective. And last, probably the most important of all, word of mouth is extremely critical to helping your business succeed in your local market. Ensuring customers are satisfied with installs may take a little extra time, but will pay off much greater dividends down the road. To ensure you're able to build an enthusiastic base of satisfied customers, make sure to work for installs that offer mutual benefit to you and your customers, provide strong customer service, and help ensure your customers have a good understanding of what to expect from a solar install. If done properly, you should have no problem getting a glowing recommendation from a homeowner and potential referrals to help you provide the same value to their friends and family. As you keep product marketing and publicity a priority in your community through whatever methods work for you, you'll ensure your successful new solar business will be around for many years to come.
SunMax, Business and Sales Training, Part 6, Facilitating Customer Financing. Once you've sold a customer on the benefits of solar, the first question they'll probably ask is, how am I going to be able to pay for it? Thankfully, answering this question is simple, as there are many affordable and readily available options out there to help pay for a solar install. When attempting to sell a SunMax system, keep in mind there are 4 main ways your customers can pay for the install. These are cash, short-term loans, long-term loans, and leasing. While cash offers the greatest savings, it's the one customers will probably use the least due to the lack of available funds to pay for the entire install cost. Recent numbers suggest that as many as 85% of solar installs are financed by borrowing or leasing. This means if you want to sell solar, you have to be able to help your customer find financing. Let's take a look at the different financing parties who can help you meet this need. First, government solar financing programs. These programs are the preferred method of financing as they typically offer some substantial advantages over other options, like lower interest rates, greater convenience, and discounts. If you want to find programs like these in the U.S., one of the best resources is Desire.org, which stands for Database of State Incentives for Renewables and Efficiency. Not only will the site help you find financing options that are cheaper and more flexible, you can also find grant and rebate programs available to your customers. Familiarize yourself with what options are there, and you can ensure your customers will get the best deal possible. Another great place to look when financing a SunMax system is Ubiquiti's list of partner loan providers. This list can save you time and hassle by pointing you towards larger financial institutions who have already expressed a willingness to work with SunMax solar contractors. See this list in our knowledge base article, Pre-Sale, Loan Partners, and Process. Still, if you find none of these meet your customers' needs, there are plenty of third-party sites where you can search for solar financing in your region. A good example of one of these sites is EnergySage, where you can get a list with details of many of the larger financing programs available to your customers in your state. Of course, a quick Google search will turn up plenty of good results as well. While these options should be plenty for your customers to choose from, in some cases, customers will want to work with a local bank for financing. In these cases, it would be worth your time to introduce yourself to local bankers and see what options they can offer for your customers. While these may not always offer the absolute lowest rates, they provide a degree of service and accessibility that many customers will find essential to purchase a solar system. All these different options we discussed today make buying solar easier than ever before. Research them and take notes of what rates and terms they offer. Having this information can help you find immediate options when speaking with a customer on site and will be critical in closing the sale. SunMax, Business and Sales Training, Part 7, Finding Local Partners. While many West may have an electrical background, in order to get solar installs inspected and approved, some states require a licensed electrician to oversee the install. In a number of states, this electrician will need to be certified as a solar contractor. Getting certified to install solar in some states can be something you can complete with little time investment. However, in other states where the requirements are more strict, it may be necessary to partner with an electrical contractor. Research your regulations and make sure your solar business meets the necessary requirements to sell and install solar. Where can you find a local electrician to partner with? First, utilize your network. Contact colleagues or friends that may be able to help you find someone to work with. By finding a partner through your network, you can find ideal contacts with a good reputation and references. If you are unable to find a contact through your network, you can reach out to the city or jurisdiction who ultimately inspects solar installs to get recommendations for electricians who would be good to work with. Second, use local classifieds. If you will look in your local classifieds in the newspaper or online, you usually find a number of certified electricians offering contracted work. These electricians are looking for just the kind of work you're in need of. Reach out to them and see if they would be a good fit. Even if they aren't qualified to install solar or interested in that line of work, you can network with them to find someone that would be the right fit. Third, look up local electrical and solar consulting companies. There are a number of companies that provide electricians for jobs and in most cases will have ample experience working on solar installs. Although costs may run a little higher by using these companies, they ensure your electrical contractor is qualified and prepared for the job. Fourth, utilize SunMax's list of solar experts. SunMax has collected a number of electricians and experts who are willing to partner with WISP in getting their SunMax business going. Reach out to our support team through the chat on SunMax Design to get recommendations for partners.
Whatever method you use, remember that SunMax is affordable enough as to allow you to pay an electrician while still offering great profits for you and your business.
Lesson 2.1. What is electricity? Electricity is a form of energy that deals with the movement of charged particles, primarily electrons. Electrons are negatively charged particles that orbit around the positively charged nucleus of an atom. Charged particles move according to the law of electric charges, which states that, while positive and negative charges attract, like charges, such as two electrons, repel each other. A conductor is any material that allows electrons to flow easily, such as a metal wire. As electrons move along a conductor, they repel other electrons in the same direction. The driving force that causes these electrons to start moving is known as charge potential difference. Charge potential difference compares the relative charge of two different areas. Based on the net charge difference, one area is either negative or positive in relative comparison to the other area. Here is a diagram showing the charge potential of a battery, a source of electric power, with negative and positive poles. The charge potential of the negative pole is considered negative since it has more electrons than the positive end. Given this difference in net charge, the electrons flow from negative to positive. To review, electricity is the movement of charged particles. Opposite charges attract, while similar charges repel each other. Charge potential difference compares the relative charge of two different areas, negative or positive, relative to each other. Lesson 2.2. Electrical circuits and diagrams. The path along which charged particles move is called an electric circuit. The purpose of a circuit diagram is to illustrate the path of charged particles as they move between areas of different charge potential. It also shows how various components are connected in the electrical circuit. A typical circuit consists of three main components: a power source, conductors, and a load. A power source supplies charge potential, that is, electricity for the circuit. A load is any electrical component that uses electricity for some purpose. Here, a battery supplies electrical power to a light bulb. The light bulb then converts the power to light. When the circuit is closed, meaning the power source, conductors, and load are all connected, electrons begin moving from areas of higher to lower charge potential. When the circuit is opened, meaning the components become disconnected, the electrons stop moving. A switch is a component capable of opening the circuit to prevent electricity from flowing. A light switch is a simple device that opens or closes a circuit, providing electricity to the light bulb. To review, an electrical circuit represents the path along which charged particles flow. A typical circuit generally consists of a power source, load, and conductors. The power source supplies charge potential, whereas the load uses the charge for some purpose. And finally, a switch opens or closes a circuit. Lesson 2.3. Properties of electricity. To better understand electricity, we'll next examine Ohm's law. The wheel of Ohm's law relates four basic properties of electricity: voltage, current, power, and resistance. These equations are not only useful in calculating real-world values, but also in understanding the true relationship between each variable. Let's look first at voltage. Voltage represents the charge potential difference between 2 points and is measured in volts. Using a voltmeter tool, we can measure the voltage between 2 points in a circuit. A low voltage battery rated to 1.5 volts has 1.5 volts of potential at the negative end and 0 volts at the positive end. Higher voltage circuits can have enormous potential to move large amounts of charged particles. For example, electrical power lines typically carry over 100,000 volts between power companies and customers. Current represents the rate at which charged particles flow through the circuit and is measured in amperes, or amps. Using an ammeter tool, the current of this circuit is measured to 10 amps. Now let's examine power, which is a measurement of work, or the rate of electricity passing at any instant in a circuit. Power is measured by wattage, or watts. Power is positively correlated with both voltage and current. This means that as either voltage or current increases, electrical power increases by the same factor. Only use electrical components, tools, and gear for the rated voltage, current, and power levels. Resistance represents the degree of opposition an electric current encounters across a circuit. A good wire conductor, like copper, is described as highly conductive. Materials that do not conduct current well are called insulators. Insulators, like PVC, which often surround the wire conductor, prevent the electric current from leaving its intended path on a circuit. To review, Ohm's law directly relates voltage, current, power, and resistance. Voltage represents the charge potential difference between 2 points and is measured in volts. Current represents the rate at which charged particles flow through the circuit. Measured in watts, electric power is an instant measurement of work. Power is positively correlated with current and voltage. Resistance is the degree of opposition faced by electric current. To produce an electric current, voltage must be great enough to overcome the resistance in a circuit. Lesson 2.4: Series versus parallel circuits. When describing how components are connected in an electrical circuit, series and parallel are the most common methods. Let's first begin by examining series circuits. In a series circuit, charge follows a single path. This means that if a single component becomes disconnected, electricity can no longer flow through the circuit. Throughout a series circuit, current is measured equally. Furthermore, voltage is cumulatively measured throughout a series circuit. For each power source, voltage is additive. For each load, voltage drop is also additive. Voltage drop represents the power consumed by a load to perform work. Here, 2 batteries supply a total of 18 volts power to a single string of 3 light bulbs connected in series. Voltage drop measures 6 volts across each light bulb. Now, let's examine parallel circuits. In a parallel circuit, charge follows 2 or more paths. This means that if a component along one path becomes disconnected, then electricity can still flow along the other paths. In a parallel circuit, voltage remains the same across each path. This means that each load draws the complete voltage potential available from the power source. In a parallel circuit, current is measured cumulatively along each path. Of the 3 amps of total current available for this circuit, each light bulb in parallel draws 1 amp of current. To review, a series circuit provides a single path for charge. Voltage is cumulative, whereas current is the same throughout. A parallel circuit provides multiple paths for charge. Current is cumulative, whereas voltage is the same across. Voltage drop represents the voltage drawn by a load to perform work. Lesson 2.5: Energy consumption and production. Power and energy are 2 related characteristics of electricity. Power is an instantaneous measurement that represents electrical work. Using the equation power equals voltage times current, you can determine how many watts of power are being generated by a power source or consumed by a load. 1,000 watts is equal to 1 kilowatt, a common reference in the field of energy. Compared to power, an instant measurement, energy is a measurement of power over time. Energy is measured in watt-hours, which corresponds to power either produced or consumed over a time interval. Watt-hours are often mentioned on energy bills. A single kilowatt-hour is equivalent to 1,000 watt-hours. and could cost anywhere from 10 cents to 30 cents for most customers in the United States. To better understand the relationship between power, energy, and cost, let's examine a light bulb with a power rating of 50 watts. When left on for 12 hours, a 50-watt light bulb consumes 600 watt-hours. The chart to the right tracks the power and energy consumption of the light bulb. During intervals where the light bulb uses power, total energy consumption increases. When left on for 24 hours, the 50-watt light bulb consumes 1.2 kilowatt-hours. When left on for 30 days, the 50-watt light bulb consumes 36 kilowatt-hours. Based on an average cost of 15 cents per kilowatt-hour, a 50-watt light bulb draws $5.40 in electrical bills for a month. To track energy consumption, power companies commonly use some form of electrical metering. Net meters track both energy consumption as well as energy production. Here is an example customer premise whose total energy load measures 2.25 kilowatt-hours over a 24-hour period. To offset the electrical bill, the customer installs a SunMax residential solar energy system consisting of 6 250-watt AC modules. After just 1.5 hours of peak production, the SunMax energy system has produced enough power to energize the customer's loads for the entire day. To review, power is the product of voltage and current at a given instant and is measured in watts. Energy represents power over time and is measured in watt-hours. Through net metering, power companies track energy consumption and production. Lesson 2.6: Alternating versus direct current. Since electricity was first studied, two types of current have existed: alternating and direct. With alternating current, the flow of charge periodically changes direction. AC operates at 50 or 60 Hz, meaning current alternates direction 50 or 60 times per second. AC is the form of current used worldwide by power companies, transmitted over power lines to residential and business customers. Any device that plugs into wall receptacles relies on AC for power. With direct current, the flow of charge only follows one direction. DC has common place in batteries, solar cells, and most electronics. Inverters change power from DC to AC, while converters change power from AC to DC. To review, AC power changes the direction of current 50 to 60 times per second. DC power, however, does not change direction. AC is widespread in power distribution, while DC is common in batteries, solar cells, and electronics. Inverters change power from DC to AC, while converters change power from AC to DC. Lesson 2.7: Distribution of electricity. Electric power companies, also known as utilities, generate AC power using a number of different fuel sources. This AC power is transmitted and distributed to customers across the utility grid, a vast network of transmission lines that carry electricity from end to end. Eventually, high voltage electricity is downconverted to lower voltages using devices called transformers. In many countries, including the United States, it is common to transition 3 wires to the customer premise, 2 of which carry voltage, lending to their name hot conductors. This AC system is nicknamed single and split phase service, since these conductors are offset by 180 degrees of phase, carrying either of 2 voltages across residential circuits. While electrical standards, including plug types, vary by region, voltage typically ranges from 110 to 240 volts for residential systems. To review, power utilities distribute AC power over transmission lines. transformers step down high voltage to low voltage power acceptable for customers. And finally, electrical standards vary by country. Voltage typically ranges from 110 to 240 volts for residential systems. Lesson 2.8 Mains Electricity. Mains electricity refers to the AC system connecting customers to the utility grid. In the United States, most customers are connected to a 120-240 voltage AC system consisting of 3 wires, line 1 and line 2, the hot conductors each carrying 120 volts, as well as the neutral conductor, a wire designed to carry 0 volts in circuits. These wires pass through an electrical meter before eventually terminating at a box called the main AC service panel. This panel is known by a number of different names, each of which helps to describe its purpose. Main AC panel, receiving AC power from the utility. Distribution board, load center, distributing power to loads located on site. Breaker panel, fuse box, providing overcurrent protection. By examining a sample circuit, we'll see how AC power is carried from the panel to a load. Line 2 and the neutral conductors branch off bus bars inside the panel to begin the circuit. A bus bar is a metal plate conductor, often to which a circuit breaker is installed. A breaker is a kind of overcurrent protection mechanism, a device whose job is to open the circuit should the circuit current exceed the maximum rating. While the main breaker for the service panel is rated up to 100 amps, the circuit breaker for the load is rated up to 15 amps. For safety reasons, a circuit breaker is installed for each AC load, which can prevent damage to equipment, electrocution hazards, or even fire incidents. When an AC plug is connected to the wall outlet, the circuit becomes closed. In this case, 120 volts passes from line 2 into the load, with 0 volts of current returning back to the panel via the neutral conductor. Here is the same AC system as represented by a circuit diagram. In some circumstances, as much as 240 volts AC may be required to power the load. Here, the neutral conductor is replaced by line 1. Between line 1 and line 2, the hot conductors, a total of 240 volts passes through the circuit. To review, mains electricity refers to the AC system for grid-connected customers. In the United States, 120-240 voltage AC power is delivered over 3 wires. The main AC service panel distributes power to separate circuit loads. Circuit breakers are overcurrent protection devices designed to open the circuit for safety reasons. While current rating varies, AC loads are typically powered using either of 2 voltages via a hot and neutral conductor or via 2 hot conductors. Lesson 3.1 Overview of the PV system. To better understand how the SunMax residential solar energy system works, we'll examine each piece of the hardware and the purpose that it serves. The PV cell is a small, individual component. As sunlight reaches the PV cell, electrons become excited and move along a semiconductor material, producing an energized DC circuit. These cells are connected in series to form a PV module, or PV panel, and produce a power rating relative to factors such as cell efficiency, material, and more. The collective group of panels that make up an entire solar energy system is called the PV array. The junction box, located on the back side of the PV module, is a protective terminal enclosure for current-carrying conductors to join the panel. These conductors run through special weather-resistant conduit into the microinverter, a device whose job is to change the DC power produced by the panel into AC power at maximum possible efficiency. A PV module that features its own microinverter is commonly called an AC module, since trunk cabling on the AC side of the microinverter interconnects with other AC modules. Y cables are trunk cables that feed directly from the microinverter. Jumper cables are trunk cables that interconnect the Y cables of a group of modules called a string or branch. Trunk cables are also used to connect strings of up to 16 AC modules to the end-run assembly, a device whose purpose is to run the conductors back to the main AC service panel. The solar gateway is a device that collects data from each microinverter, communicating either wirelessly or via the power line connection, or PLC for short. Together with the mounting kit, this hardware makes up the entire SunMax residential solar energy system. To review, the following hardware components make up the SunMax residential solar energy system, including individual PV cells, PV modules or panels, junction boxes, microinverters, trunk cables, strings or branches of AC modules, the end-run assembly, solar gateway, and the mounting kit. Lesson 3.2 IV curve. In the field of photovoltaics, an IV curve diagram describes the power performance of a solar module based on current and voltage. Here, the IV curves for a sample 285-watt module are plotted, showing 3 different scenarios. The blue curve represents standard test conditions, or STC for short. Under standard test conditions, a module is subject to an irradiance measurement of 1,000 watts per square meter. That is to say, peak sunlight at sea level, as well as a cell temperature measurement of 25 degrees Celsius, or 77 degrees Fahrenheit. The green curve represents nominal operation or operating cell temperature, or NOCT for short. Under NOCT, a module is subject to a slightly lower irradiance measurement of 800 watts per square meter, just under peak sun level, as well as an ambient temperature reading of 20 degrees Celsius or 68 degrees Fahrenheit. Compared to STC, the cell temperature reaches 48 degrees Celsius, about 120 degrees Fahrenheit, under NOCT conditions. The purple curve represents more real-world conditions, with peak sunlight and a cell temperature rating of 60 degrees Celsius or 140 degrees Fahrenheit. So, although the panels are rated to a maximum power of 285 watts using standard test conditions, the actual achievable power varies widely. This is because power produced by a module is dependent on voltage and current, both of which are directly affected by cell temperature and irradiance, respectively. Before examining these relationships, let's reinforce some of the characteristics of the IV curve, namely the equation power equals current times voltage. Using an example module rated to 285 watts, the maximum power point is reached under standard test conditions, where the maximum power voltage is 37.5 volts and maximum power current is 7.6 amps. IV curves also reference the open circuit voltage and short circuit current, values that are helpful when troubleshooting the equipment, like what voltage to expect of an individual panel when disconnected from the microinverter. Now, let's examine the effects of temperature on power output, specifically the temperature of a PV cell. Voltage and cell temperature are inversely related. This means that as cell temperature increases beyond standard test conditions, voltage decreases. Factors accounting for increased cell temperature include, first and foremost, solar radiation, as the darkly colored PV cells induce higher levels of heat throughout the day when exposed to sunlight. For example, when faced with an ambient temperature of 30 degrees Celsius, 86 degrees Fahrenheit, solar modules could reach temperatures of 65 degrees Celsius or 149 degrees Fahrenheit. Among other factors, wind can play a significant part in helping to cool panels. In areas of excess heat, it is arguably cheaper to install extra PV modules to compensate for decreased system power output rather than invest in complex, dedicated cooling systems. Wind testing systems use a temperature gun to measure the surface temperature of a PV module. Next, let's examine the effects of irradiance on power output, where irradiance represents the density or amount of sunlight available. Current and irradiance are positively correlated. This means that as irradiance levels decrease or increase, current will also decrease or increase. Irradiance or insolation vary by geographic location, where areas closer to the equator at higher elevation levels encounter the greatest amounts of solar exposure. Despite the relatively low irradiance seen in areas like Germany, solar has and continues to prove itself as a viable investment given increasing utility cost, reduction in system pricing, and program incentives for commercial, residential, and all customer types. Other factors that affect irradiance include the elevation, tilt, and orientation of the PV array. Use Ubiquiti's design software to help orient and align your panels to achieve peak power output. Like with temperature, it is arguably cheaper to install extra PV modules to compensate for decreased system power output, rather than invest in expensive mechanical tracking systems designed to maximize solar exposure. Finally, clouds, dust, and an especially important factor, shading, since systems can be designed to avoid shading from objects like trees, buildings, power lines, and more. When testing systems, use a pyranometer to measure irradiance levels at any given moment. To review, an IV curve represents the power performance of a solar module. Standard test conditions plot power performance with an irradiance rating of 1,000 watts per square meter and an average cell temperature of 25 degrees Celsius. The maximum power point on an IV curve is the point where voltage and current produce peak power. Real-world performance varies from STC, since irradiance and temperature ratings are subject to location, as shown by the nominal operating cell temperature and demonstrated in the real world. Voltage and temperature are inversely related, while current and irradiance are positively related. Lesson 3.3 PV and Inverter Output Circuits. Distributed generation systems, like the SunMax residential solution, typically produce DC electricity that is converted to AC power by means of an inverter, such as the SunMax microinverter. Despite its name, the SunMax residential AC module also represents a separate, unique DC source circuit. Also known as the PV output circuit, this represents the DC side of the microinverter, that is, the DC circuit wiring passing through the junction box of the panel across all the PV cells. Each PV cell supplies approximately 0.5 volts of potential, so to achieve 250 watts of power, here 60 cells are connected in series to provide a total of 30.1 volts with 8.3 amps of direct current. Maximum power point tracking technology allows the SunMax microinverter to identify the optimum DC voltage and current in order to operate at peak AC power output, despite variance in temperature and irradiance throughout the day. In addition to the DC circuit, the AC module also connects to a string of other modules in a parallel AC circuit, leading back to mains AC service equipment. Also called the inverter output circuit, this represents the AC side of the microinverter, which includes the AC circuit conductors through the end run, main panel, and ultimately back to the grid. Typically, in areas where net metering is the standard for utility energy agreements, the inverter output circuit is connected to the main AC service panel, representing a load side connection. Conversely, in areas where feed-in tariffs are the standard for utility energy agreements, the inverter output circuit is typically connected between the main panel and the utility meter, representing a supply-side connection. The AC power supplied by the microinverter is based directly on DC side production performance. On the AC side of the circuit, the microinverter detects and supplies a voltage consistent with the mains electrical system at the customer premise. That is, the AC voltage across line 1 and line 2 conductors. In 3-wire split-phase systems like the United States, the voltage across the hot conductors is 240 volts. So for a 250-watt microinverter to produce peak power, it must output AC power at approximately 1.05 amps. Due to restraints on the current-rated components in the inverter output circuit, such as wiring and overcurrent protection devices, up to 16 SunMax residential AC modules can be connected in a single string. For customer installations that require more than 16 AC modules, connect separate branches back to the same AC service equipment. To review, the PV output circuit represents the DC side of the system. So for SunMax Residential, this includes PV cells, junction box, and DC leads on the microinverter. The inverter output circuit represents the AC side of the system, which for SunMax Residential includes the AC leads of the microinverter and conductors that tie into the mains AC service equipment. For grid-connected customers, the inverter output circuit is typically connected in either of two ways, commonly as a load-side connection at the main AC service panel, like in the case of net metering, but also as a supply-side connection between the customer and utility, like in the case of feed-in tariffs. Lesson 4.1 Bidirectional Metering. Electricity meters have long been used by power companies to measure energy consumption and bill customers. In the wake of today's distributed generation model, where grid-connected customers produce their own energy, bidirectional metering provides a method for tracking both energy consumption and production. Feed-in tariffs measure production and consumption on separate meters, which lends to its nickname, buy all, sell all, since all energy used is bought, with all energy produced sold to the utility. In contrast, net metering uses a single meter for both consumption and production. Net metering benefits customers in two ways. First, since solar energy is immediately available for use at the customer premise, production can offset consumption for the billing period. Second, if production exceeds consumption for the billing period, the power company must buy back surplus energy. In most cases, power companies buy back at or near to the full retail rate of a kilowatt hour. When a power company buys back energy, they typically issue credit toward future electricity bills. So although the average residential customer is not receiving a check via mail, there are cases of entrepreneurs actually generating profit from large-scale solar farms. Across the globe, world governments are enacting policies regarding feed-in tariffs and net metering to popularize the distributed generation model. Throughout most of the United States today, net metering is not only common but also legally required by state governments for local utilities. As you generate and qualify solar customer leads, you should be aware of the rules that apply to net metering, including the maximum total power capacity for each energy system. A typical net meter may feature 3 reading modes. Here, Code 1 represents total energy consumed from the grid by the customer. Code 2 represents total energy produced and sent to the grid by the customer. Code 3 represents the difference in total production and consumption, in other words, the net flow of energy. At any given moment, an arrow indicator on the net meter shows the flow of energy. When pointing left to right, energy is drawn from the grid. When pointing right to left, energy is being sent to the grid. As production begins to exceed consumption under net total, the meter eventually counts down past 0 kilowatts, reading 99999.9 kilowatts, and so forth. To review, distributed generation refers to the network of grid-connected customers with energy-producing systems. Feed-in tariffs track energy production and consumption on separate electricity meters. Net metering tracks both production and consumption via a single meter. In most parts of the United States, utilities are legally required to participate in net metering, which benefits customers by offsetting energy consumption through production, as well as providing credit whenever surplus energy is produced. When commissioning a grid-tied PV system, make sure that bidirectional metering is installed at the customer premise, so the customer actually receives credit for their system's energy production. Lesson 4.2: Electricity Bills. Understanding electricity bills is fundamentally important when finding customer leads and designing solar energy systems. Grid-tied customers are periodically charged by the power company not only for the amount of electricity they consume, but also for the actual service provided. The charges and rates at which customers are billed for grid electricity usage are called utility tariffs. Utility tariffs vary from power company to power company, but in general are categorized into 3 groups. First, customer type, whether residential, commercial, or industrial. Second, rate schedules, tiered usage levels or seasonal rates, such as those shown in the diagram to the right. And lastly, demand levels, including duty cycles and cost to operate. Typically, these charges deal with power levels and are measured in kilowatts. The chart to the right shows 2 customers who consume the same energy total, but over different peak power levels. To compensate for the utility's investment in the capable infrastructure, demand charges may be higher for peak power users. Let's take a look at 2 sample electricity bills for a customer with and without a solar energy system installed. Here is a standard electricity bill, which presents in straightforward terms the total energy consumption for a given period. In the billing details section under Supply Services, the current customer rate plan is listed. Based on this winter residential rate, the cost per kilowatt hour drawn from the grid is about 27 cents. The service period for this particular bill covers 30 days, from November 1st to the 30th. For a standard meter, the customer is charged according to the kilowatt hour difference between the previous and current meter reading. The total supply cost is then calculated by multiplying this figure by the winter residential energy rate. The basic charge under delivery services is a flat fee relating to the customer's connection to the grid and may account for overhead and maintenance costs. Together, the delivery and supply charges equal the total bill amount for the payment period. The information shown in the electricity overview section is particularly important to potential solar customers and integrators alike. Here, each bar measures the customer's daily average kilowatt-hour consumption by month. Over the course of the entire year, this data lays the groundwork to determine the required capacity of the solar energy system. Too small of a system, and production will not offset consumption. Too large, and the customer risks a decreased return on investment. Now that we've examined the standard meter bill, let's examine a sample net metering bill, and instead, assume that the customer installed a solar energy system toward the end of January. The electricity overview section now shows daily net energy levels by month. Compared to the previous year, total consumption is much lower, since production offsets the grid energy requirement. By October, total energy production begins to exceed consumption, enough to maintain a net positive in stored energy credits over the lifetime of the customer's solar energy system. Back on the billing section under Supply Services, these credits have already accrued into the customer's account. Since a production surplus occurred again for the current billing cycle, the credit total again increases, with net consumption for the month of November at zero, and although charges for delivery services still apply, the solar energy system is shown here to reduce the customer's total electricity bill by as much as 95%. To review, utility tariffs refer to the rates and charges imposed on grid-connected customers by power companies, which include, but are not limited to, customer type, rate schedules, and lastly, demand levels. While incentives vary widely for solar energy customers, net metering relates specifically to utility tariffs seen on electricity bills. Lesson 4.3: Cost Savings and Incentives. Cost savings refer to the offset rate charges from energy consumption on electricity bills. Cost savings are the primary economic motive for buying a residential solar energy system, saving customers potentially hundreds per month, thousands per year, and tens of thousands of dollars over the lifetime of the energy system. Incentives help boost the return on investment and are available through special utility and government programs. Although incentives vary widely across different locations, here are a few of the most important types of incentives available to residential customers in the U.S. The Investment Tax Credit, or ITC for short, is a federal tax credit renewed through 2016, which grants U.S. taxpayers 30% savings from the cost of a new solar energy system. Taxpayers must file an IRS Form 5695 together with their normal 1040 tax form, so savings come as reduced tax payment or an increased tax refund. For example, a customer who spends $10,000 on a new solar install qualifies for $3,000 tax credit, reducing the net cost of the solar install to $7,000. While additional state and local tax deductions, such as grants and rebate programs, apply to both solar energy integrators and system owners, such credits may be limited in their full value when used jointly with the federal ITC. Performance-based incentives are another type of incentive that apply to rebate and contractual programs, which may pay customers based on their PV system's output or the expected production. Solar Renewable Energy Credits, or SRECs for short, are popular programs based on the requirement that regional utilities buy back a certain amount of electricity from solar customers participating in the distributed generation model. In the SREC program, a single credit is equal to 1,000 kilowatt hours, or 1 megawatt hour, and carries a value relative to the market in which it is generated. Each market is unique. In some markets, this value is highly regulated by government entities through agreements, which assures long-term value for the customer on the credit. In other auction-based markets, solar credits may have a value determined by supply and demand. Other miscellaneous cost savings may apply as well, such as an overall increase in the value of the property on which the solar install is made, since prospective owners are also entitled to rate savings on future electricity bills. Be sure to outline all cost savings when preparing the customer proposal to encourage the customer to take full advantage of the benefits presently available for solar energy systems. To review, cost savings are the result of offset energy consumption on electricity bills, the primary manner in which customers benefit from solar. Incentives refer to specific utility and government programs designed to boost the return on investment of a solar energy system. These incentives include federal, state, and local tax incentives, like the ITC for 30% tax credit on new systems. Performance-based incentives supplying assured value returns. Solar credits like those in the SREC market, as well as other miscellaneous incentives, like increased home value. Lesson 4.4: The Ideal Customer. In the sales industry, you earn money for the customers to whom you sell your product or service. Despite the cost savings for residential solar in grid parity locations, some customers may not be qualified for system installs. To qualify leads, here are 5 quick questions you can ask the customer. First, are you a homeowner? Working with the homeowner is essential since renters are legally restricted to sign off on contract work on a property. What is the address of your property? Knowing the address also allows the sales rep to quickly identify via Google Maps the location and orientation of the roof, as well as check whether significant shading is present. What is your average monthly utility bill? The long-term cost savings of solar energy systems necessitate that the customer have an electricity bill sufficiently high to significantly offset supply charges due to energy consumption. Although this varies greatly due to different rate structures and incentives, the ideal customer may be somewhere in the range of $100 per billing cycle and/or a supply rate of 12 cents or more per kilowatt hour. As early as possible, you should examine the customer's electricity bill to determine whether or not a PV system is viable. Is your roof in good condition and free of shading? A poorly maintained roof can lead to a myriad of problems, such as leaks for the homeowner, as well as safety concerns for workers. And while the PV system may not cover the entire rooftop, ideally, the intended area for install should be free of shading, if not, minimal shading for short periods. Do you have a credit rating above 650? Because most customers will require a loan to finance the PV system, the customer should have a decent credit score, although this is optional should the customer have sufficient cash on hand to buy the PV system. Assuming the customer meets these requirements, arrange a time to meet, during which you can inspect the roof, making sure it's in good condition and free of shading, estimate electrical home run requirements, such as conduits, examine the main AC panel, ensuring it supports 2 additional breakers rated to 20 amps, and finally, obtain a copy of the electricity bill. To review, these 5 questions will quickly qualify a potential lead. Are you a homeowner? If so, then what is the address of your property? What is your average monthly utility bill? Is your roof free of shading and in good condition? Do you have a credit rating of at least 650? Assuming the customer satisfies these requirements, arrange a time to meet and run a solar site survey. Lesson 4.5 Financing Options. Homeowners usually finance their solar investment in one of 3 ways: cash payment, solar leasing, and solar loans. While each of these finance methods allows customers to enjoy the cost savings of a solar energy system, the cash purchase option provides the maximum return on investment. Presently, however, as many as 85% of customers instead opt for loans or lease agreements due to the $0 down investment and immediate payback. By opting for cash purchase with a new system, the customer benefits in several ways, including a simple one-time payment for the system, immediately recuperated costs through program rebates and tax credits, such as the ITC tax credit of 30% savings. They also own and keep the system through its lifetime, which benefits in potential home sales. Overall, cash purchases provide the best return on investment, around 7 to 14%, better than most stock investments. The major hurdle to purchasing a new system is supplying the cash up front, as well as a longer period for payback. But after the payback period, the savings can be significant. And although the cash is paid up front, generally, the customer is expected to make an initial deposit, then pay the remaining balance once installation is complete. Leasing a system has some benefits, including no money down and immediate savings since there's no payback period. In contrast, there are disadvantages, including a more complex process, especially in the case that the lease is transferred to a new homeowner. Also, the customer is essentially paying to rent the equipment, so they do not own the system. Finally, there are less cost incentives and a lower return on investment for lease systems. Solar loans are similar to leasing in that there's no money down and the customer can enjoy immediate savings since there's no payback period. Solar loans also offer unique advantages, including ownership of the system after the loan is paid off, access to more program incentives such as tax credits and rebates, and in general, a better return on investment than leasing. There are some disadvantages, however, such as a less simple process like with loan transference in the case of new home ownership, and lower return on investment compared to cash purchase. To review, cash purchase maximizes the return on investment of the solar energy system Solar leasing or loans may supply a viable return on investment for financing the solar energy system. Ubiquiti works with a flexible lending partner to get fast, cost-effective solar loans for your customers. For any solar job site, safety is the #1 priority. Only qualified and experienced individuals should work with solar energy equipment. This lesson is designed to introduce safety topics to anyone working with SunMax PV equipment and is not intended as a substitute to formal safety training, such as that provided by OSHA, the Occupational Safety and Health Administration. The solar section of the Green Job Hazards page listed on the OSHA website gives a detailed overview of precautions relating to work in the solar energy field. The first hazard area to consider is fall protection, which means effective use of guardrail systems, safety net systems, and/or personal fall arrest systems, whenever and wherever necessary. A personal fall arrest system typically consists of a secure body harness attached to a line that connects to an anchor point to prevent or stop fall before injury can occur. Lack of fall protection is the #1 cause of serious accident at solar sites, so be sure to inspect, identify, and properly secure the job site against potential fall hazards. While useful, ladders must only be used for their express purpose. A Type 1 extension ladder is appropriate for climbing to job sites when placed at a 1:4 length to height ratio. However, these same ladders should never be used to carry equipment to customer rooftops and other high locations. This brings us to the next hazard area, which is crane and hoist safety. Only authorized, trained personnel should operate machinery to transport materials to solar job sites. The final hazard area for PV systems is electrical safety. Whether installing or performing maintenance on a PV system, all electrical circuits should be shut down to protect workers. Lockout-tagout describes the steps required to make the job site an electrically safe working environment. The first step of lockout-tagout is to identify all power sources at the job site. Not only should you consult the electrical diagram for the site, but also physically inspect the premise. Typically, for residential customers, this includes, but is not limited to, the main panel, which goes by many names worldwide. Also, the PV source circuit, as well as the home run that connects the PV source circuit back to the main panel. There may be additional power sources that tie into the job site, such as generators or backup battery systems, which should also be identified for lockout-tagout. After identifying all potential sources of power at the job site, qualified personnel must safely shut off and/or disconnect all power sources. This includes scheduling with the utility company to shut off power to the customer premise. The final step of lockout-tagout requires that power sources are securely locked and tagged to prevent anyone from accidentally powering a system. Tagging means labeling equipment so that only the responsible, qualified individuals may unlock and restore power to the disabled system. Only after lockout-tagout is completely performed throughout the entire job site and the PV equipment is isolated from all power sources can you begin working on the solar energy system. Although grounding relates to the electrical safety of a PV system, this is covered later in the lesson. Personal protective equipment relates to all the previously mentioned areas, including electrical, physical, and mechanical hazards posed to the worker. At a minimum, consider the following personal articles for protective equipment: a personal fall arrest system, ANSI 787 eyeglasses, an ANSI 789 hard hat, suitable footwear for each given task, and electrically insulated gloves when performing maintenance and testing energized PV systems. And when working on live and/or grid-connected systems, be sure to use arc flash protective equipment properly rated for the voltage of the electrical system. To conclude this important lesson, you are responsible for your own safety. Ubiquiti assumes no liability for the work you perform on PV systems. Ubiquiti strongly recommends you participate in additional safety training to properly identify and account for all electrical, physical, and mechanical hazards when working in the solar energy field. Lesson 7.1 SunMax Install Time-Lapse. The following video depicts a 9-module array roof installation from start to finish. After measuring and marking rafters for install, compartmentalize tasks in a team as you drill, bolt, and fit the mounts and flashing to the rooftop. An additional flashing piece is used with tile rooftops. With the mounts securely in place, insert the first row of mounting assemblies, then tie a leveling string at both ends to adjust the height of the assemblies until they are the same across each row. Portrait and landscape trim covers run along the bottom row and are secured by a lock mechanism. Insert panel connectors with arrows lined to the marks on the back of the trim. Panel connectors join panels along each row. Proceed to hook and lower panels into the bottom row of mounting assemblies. After scanning the QR code into the customer site for the SunMax mobile app, insert mounting assemblies and panel connectors along the top side of the panel to stabilize and bond adjacent panels throughout the array. On rare occasions, connector mounts substitute panel connectors in the event that a mounting assembly coincides with the spot of a panel connector. Using portrait and landscape Y cables, continue connecting rows of adjacent modules. Using jumper cables, connect different rows of modules. Cable clips hide and protect all trunk cabling throughout the array. A single end-run kit transitions the trunk cabling to wire conductors for up to 16 modules, while a single gateway communicates with all of the microinverters in the array. To review, be sure to complete the free online training course and read through all the SunMax documentation, which explains the function of each component and outlines each step in the installation process.
Lesson 7.2 Site Prep and Staging. With final permits approved and in hand, you can move to prepare the site for installation. The first step is to order customer equipment. The final bill of materials will be generated by the final customer site design plan. Equipment can either be ordered directly from Ubiquiti store for U.S. customers or through local distribution partners. It may be a good idea to ship directly to the customer premise to avoid having to unnecessarily transport equipment. Whether working alone or with a contracted electrician, you will also need to purchase supplies for a customized end run to carry electrical wires back to mains AC service equipment. This includes, but is not limited to, conduit, wires, nuts, and overcurrent protection devices, and possibly an AC disconnect, as well as a new main AC service panel, all of which should be rated to the system ampacity. Besides scheduling on a day when weather is appropriate, you should also schedule the install at a time when the homeowner is present in order to gain access to the roof and main AC service panel, and potentially other areas of the house, like the attic, should you need to identify the location of rafters. You may also need to contact the local utility prior to installation to acquire a bidirectional meter and/or shut off power to the home, like when a supply-side connection is planned. Make sure that you've also downloaded and installed the latest version of the SunMax Install app on your Android or iPhone device. The Install app lets you register and provision each microinverter, as well as the solar gateway for remote monitoring and management in the SunMax software. It is also recommended that you download the SunMax user guide to your mobile device, which you can use as reference during install. The user guide contains information relating to array mount spacing, specific to the site location, as well as detailed step-by-step instructions. On the day of installation, make sure that the site is clear of hazards and ready for work. Then proceed to set up ladders and install anchor points for safety purposes. Use caution when transporting materials to the job site. Work in teams of 2 to properly lift, carry, and place the panels. Pick up and hold the panel at the corners to distribute weight evenly and avoid straining the metal lips. Modules and other heavy equipment should be safely transported to the rooftop using equipment like a hoist mechanism. Weather conditions may cause you to reschedule installation. To review, with permits in hand, order customer materials, including SunMax equipment, as well as end-run conduit and wiring. Schedule the install when the customer can give you access to the roof and other parts of the home. Download the mobile app and SunMax training guides as well as documentations to help you through the install process. Lesson 7.3 Measurements, Markings, and Mount Points. As you begin installation, be sure to adhere to all local rules and regulations with regards to measurements and spacing from roof edges, eaves, and ridges. The key to efficiently install the SunMax residential system is to become familiar with each step, completing tasks in a compartmentalized fashion. For example, rather than mark chalk lines for only a single section of the array, consider marking all of the chalk lines before proceeding to the next step. Based on the final SunMax site design, you'll need to measure and mark the position of roof mounts on the rooftop. Mark the location of the first row of roof mounts by placing a chalk line horizontally across the roof, that is, 1.5 inches up from where the lower edge of the solar array will sit. Next, mark the location of the second row of roof mounts by placing a parallel chalk line up from the first using the following guidelines. For portrait designs, mark 66 inches, or 1,675 millimeters up from the previous chalk line. For landscape designs, mark 40 1/8 inch, or 1,020 millimeters up from the previous chalk line. Repeat these steps as necessary for additional rows. Next, mark the center line of each rafter, perpendicular to the horizontal chalk lines. These marks should be made to within 1/8 of an inch, or 3 millimeters, of the center of the rafter. With the initial chalk lines made, identify the first mount location by locating the closest rafter underneath the outside edge of the first AC module in your array. Mark the center of the first rafter that will support the lower edge corner of the first AC module in your array. Ensure that the location does not exceed the maximum cantilever distance of 15 3/4 inches, or 400 millimeters for portrait designs, 19.69 inches, or 500 millimeters for landscape designs. If a rafter does not fall within the maximum cantilever distance based on the current chalk line position, the AC module location will need to be shifted in order to reduce the cantilever distance. Once the first roof mount location is marked, continue to mark additional roof mount locations along each horizontal chalk line, observing the maximum mount spacing for your location until the desired array layout is complete. Ensure that the cantilever distance has not been exceeded at any other locations in your array, including the opposite side from where you started. Finally, place roof mounts at line intersect points in position for roof penetration and flashing. To review, based on the final SunMax site design plan, measure and mark lines for roof mounts, taking into consideration the roof requirements for spacing and loading based on the location of the install site. Once finished, place the mounts at intersection points to begin roof penetration and flashing. Lesson 7.4.1 Penetration and Flashing for Shingle Rooftops. The purpose of flashing is to ensure that roof penetrations are fully weatherproofed. Throughout this section, use caution when making penetrations to minimize risk to the rooftop. Roof shingles first need to be cut. Use a chalk stick to mark a 2-inch or 50 millimeter area around the roof mount. That will be used as a guide as you trim the second course of shingles. Once the shingles have been trimmed, position the roof mount over the center of the rafter. Then, carefully begin pre-drilling the 2 larger holes that will be used to secure the roof mount to the rafter. Use the shingle cutout and the 2 smaller holes on the roof mount as a guide for positioning. To avoid damaging the roof mount, do not drill the holes completely through with the roof mount in place. Remove the roof mount temporarily and finish pre-drilling 2 3/16 inch or 4.8 millimeter holes, approximately 2 inches or 50 millimeters deep. Make sure you cover both hole openings with roofing sealant. This will ensure a watertight installation once the lag screws have secured the roof mount to the rafter. Position the roof mount back into place and secure it to the roof structure using the provided lag screws until it is fully seated. Slide a pry bar or shingle ripper under the roof shingles where the flashing is to be installed to break the bond between the roof courses. Also remove any nails from shingles that interfere with the flashing, as they will degrade the weatherproof ability of the system. Apply roof sealant to the underside of the flashing, spreading it evenly across the bottom surface. Slip the flashing into place underneath the upper course of shingles. Then, lower the flashing into place over the roof mount. The flashing should be installed so that the Ubiquiti logo faces toward the front. Replace the shingles to cover the roof flashing. The flashing should be positioned so that the lower edge does not extend beyond the edge of the first course of shingles, with the upper edge of the flashing being located underneath the third course of shingles. Apply a minimum of 1/4 inch or 6 millimeters continuous roof caulking around the gap between the flashing and roof mount. Finally, install the rubber counter flashing over the neck of the roof mount until it is fully seated onto the flashing. To review, the purpose of flashing is to ensure that roof penetrations are fully weatherproofed. Roof shingles first need to be cut to allow proper installation of mounts and flashing materials. Use caution when penetrating the customer rooftop, applying roofing sealant to cover any gaps in the mount and flashing system.
Lesson 7.4.2 Roof Penetration and Flashing. Tile. When installing the composite roof mount and flashing, follow the instructions in the previous lessons, including the shingle rooftop flashing video, as you measure, mark, and remove tiles to install roof mounts and the flashing material. It is highly suggested that you apply a layer of roofing sealant and reinforcing material around this standard flashing material to prevent any leaks. After the roof flashing is ready, proceed to insert tiles one by one as you measure, mark, and then remove them to cut a conservatively sized space through which the roof mounts will penetrate the tile. To cut the tile material, you can use an angle grinder paired with a masonry blade or a 2-inch masonry hole saw. Once cut, place the tile back into position. The final step is to shape the tile flashing to fit the contours of the tile material. Once shaped, slide the tile flashing underneath the tile, then securely install the extension post before applying roofing sealant and seating the rubber cap. To review, after the roof mount and flashing are installed, proceed to measure and cut an area in the tile roof through which the roof mount will protrude. Once cut, place the tile back into position, then shape and fit the tile flashing to fit the contours of the tile material before installing the posts with roof sealant and the seated rubber cap. Lesson 7.5 Mount and Trim Kit Install. With the flashing installed, begin to insert and install the first row of mounts. At each end of the first row, measure and adjust the mounting assemblies to the same height. The mounting assemblies swivel to increase or decrease the height. Then tie a string at both ends to bring the mounting assemblies to the same height across the entire row. Note that the mounting assemblies for subsequent rows should also be at the same height as you insert them into the frames of modules you are installing. Hook the trim covers onto the mounting assemblies. Then insert panel connectors at trim cover gaps as well as alignment marks on multi-panel trim covers. Finally, secure the trim kit by fastening the trim lock to the mounting assembly. To review, install mount assemblies at equal height across the bottom row, then add trim kits and panel connectors to begin installing panels.
Lesson 7.6 Module Assembly and Cabling. With the trim covers installed properly, you're now ready to place and install the first row of AC modules, which will structurally fasten to neighboring modules in the same row. Jumper and Y cables are also connected in this video tutorial. Use the same techniques described here to install modules at any row in the array. Begin by hooking the AC module onto the top lip of the mounting assemblies at a 45-degree angle. Then, Lower the module while pulling its top edge toward you to keep it securely in place at the mount. As mentioned in the previous video, the remaining roof mount locations should not have mounting assemblies installed yet. Holding the AC module in position, insert the mounting assembly hardware into the top edge of the panel, with the arrows facing forward, and line it up over the roof mounts in the next row. If the AC module is supported by more than one mounting assembly or connector mount, ensure that each component is inserted into the top edge of the AC module before securing it to the roof mounts. While lowering the AC module into place, continue to pull its top edge slightly toward you to ensure that it remains hooked onto the swivel mounts in the previous row. Secure the AC module to the roof mounts using the mounting hardware. If the AC module is not seated properly or sitting evenly with the mounting hardware in row 1, then make the necessary adjustments. If adjustments need to be made to one or both of the mounting assemblies, turn the mounting assembly base in either direction to adjust its height. Once the mounting assemblies are all at the same height, secure the AC module to the roof mounts. Subsequent AC modules can be installed in a similar manner as the first module. However, be sure to connect AC trunk cables between neighboring modules before completely lowering and securing each module to the roof mounts. Adjacent AC modules whose corners sit at a common mount point are structurally supported and electrically bonded by the mounting assembly. If the corner edges of the AC modules do not rest at a common mount point, use a panel connector to join the AC modules together. Panel connectors hold the AC modules together structurally along the frame edges and corners while also bonding them together electrically. The final layout of the array may prevent you from easily accessing the modules later in the install, so after cables and modules are connected, be sure to properly fasten and securely clip cables to the lips on the underside of AC modules. This will suspend the cables above the rooftop and keep them from being exposed to the sun and other harsh weather elements. Continue installing AC modules, working from side to side until the layout of your solar array is complete. In a multi-row system, jumper cables are required to connect sequential rows of AC modules as described in detail in Appendix B of the SunMax user guide. Use clips to fasten these jumper cables to the underside of the modules as well. Once the last AC module in your array has been installed, locate the open Y cable in your string of AC modules and attach it to the end run assembly. Repeat this step for each string of up to 16 AC modules. To review, AC modules hook onto the top lip of the mounting assembly. Connect trunk cables, then carefully lower the modules into place and secure the mount assemblies at the same height across each row, securing trunk cables to the underside of the modules as you continue to install modules across the array. Lesson 7.7 End run to mains AC service equipment. When working on the end run, it is vital that the main breaker and any alternative power sources are turned off so that the AC circuit is de-energized for safe work conditions. Also, be careful not to cut or damage the insulation of the wire conductors when preparing the end run. When terminating connections, the connection wire leads should be cleanly installed with special care that insulating jackets do not prevent a clean termination. Finally, be sure to adhere to local guidelines for wire gauges, installation, and electrical work requirements. Ubiquiti highly recommends that you work with a licensed electrician in your area to complete these tasks. The tools you'll need to complete this section include small flat blade and number 2 Phillips screwdrivers, wire strippers, 10 to 12 AWG or 3.3 to 5.3 square millimeter THWN-2 wires, color-coded according to the site requirements, half-inch liquid-tight flexible metal conduit or electrical metallic tubing, half-inch national pipe thread for North American end-run assemblies, or M20 by 1.5 for European end-run assemblies, conduit bender to prepare the conduit, as well as a hacksaw or pipe cutter to make cuts, and a conduit reamer to smoothen sharp edges so conductors do not become damaged, and a 13mm wrench. The end run refers to the inverter output circuit, which can actually be either a load side or a supply side connection. Generally speaking, the end run refers to the AC side wire conductors that connect one or more strings of SunMax modules to the customer mains AC electrical system. Here, a load side connection is shown. In this load side example, the end run assembly transitions the AC trunk cabling from the SunMax solar array to separate wire conductors that ultimately connect back to the main AC service panel. When choosing the location for the end run assembly, consider a corner section of the array that is close to where the main AC service equipment sits or nearby the point of roof penetration for end run wiring. Only one end run assembly can be used for each string of up to 16 AC modules. To begin, using a flat blade screwdriver, remove the end run cover by gently prying the locking tabs outward and sliding the cover off. Locate the open Y cable connector at the end of the array of AC modules and connect the end run cable until it is firmly seated. Note that a single end run assembly can only be used for a maximum of 16 modules. For example, an array of 30 modules would have 2 assemblies minimum, and strings of, say, 16 and 14 modules respectively, but not 17 and 13 modules, since this would exceed the 16 module per string maximum. Next, the wire conductors as well as conduit should be measured and cut to lengths that meet local requirements. Thread the conduit connector into the end run cover. Pass the wire conductors safely through the conduit and the cover of the end run assembly. Secure the conduit to the NPT or M20 by 1.5 connector and install the appropriate wires into the respective terminal block locations inside the end run housing, that is, line 1, neutral, line 2, ground for the North American end run assembly, or line, neutral, ground for the European end run assembly. Slide the end run housing into the cover until it snaps securely in place. Now position the end run assembly underneath and parallel with the outside edge of the AC module, preferably with the conduit side connection facing downhill. Spread the conduit support clamps open and fit them over the conduit with the non-threaded screw hole facing out. Then, pre-install the screw into the clamp until the screw thread is visible and protruding from the opposite side. Hook the conduit clamp on the inside lip of the AC module and then over the outer lip. Tighten the screw on each conduit clamp to support the conduit on the AC module. On the opposite end of the string of AC modules, terminate the open Y cable connector using the cable end cap. To review, before working on the end run, the AC service equipment should be completely de-energized for safe work conditions. It is highly recommended that you work with a licensed electrician to ensure that local requirements are met relating to the end run wiring, conduit path, and general electrical work. A single end run assembly should be used for each string of up to 16 AC modules. The location of the assembly should take into consideration roof entry and/or panel access. The wiring feeds through conduit and connects to the special end run assembly for the customer site. The end run assembly clamps underneath the array, while the opposite end of the string is terminated using the cable end cap. Lesson 8.1 SunMax Site Monitoring. Before you can monitor a customer's site, you'll need to complete your first installation using the SunMax mobile apps for Android or iOS. Customer sites are listed and can be sorted by column. Click on a customer site to see information as it relates to the power and energy produced by the SunMax system. To review, the ability to monitor the system allows you and your customers to track the performance of the SunMax system, allowing you to more effectively market to prospective customers. Together with the monitoring software, you can upsell operations and maintenance support to the customer for increased monthly profits over the lifetime of the system. Via the Solar Gateway, The SunMax monitoring software shows both real-time and historical data regarding the power and energy production of the solar energy system. In general, the monitoring software relates the performance and status of the microinverters. Production varies normally over the course of a 24-hour period based on irradiance and temperature measurements. Microinverters may appear offline for a number of different reasons. For example, whenever there is insufficient power on either the DC or AC side of the microinverter, it will shut down operation. This is normal and expected, like during nighttime hours or when grid service goes offline. Inspect the AC module if the microinverter goes offline during normal hours. Inspect the gateway and end run if the entire array or select module branches go offline during normal hours.